Hi everyone. Hello. Hello
Good
for those
morning.
who are online.
Good morning, everyone. Welcome to today's episode of Space Ag Updates. And today we are going to have a exciting conversation with our space ag expert, Davi Souza, who you see. Davi, show off your nice T-shirt there,
Oh
so
yes.
everyone can see.
I'm
He's set.
sexy and I grow it.
There you go, right there.
In
Um,
space and on Earth.
in space and on Earth. Um, So this Agritecture merch is available to those who are located in the US. We'll post a link later. But as we're waiting for folks to join us today, why don't you add in the chat where you're joining us from?
Yes, don't forget that the Space Ag updates is the moment for you all that is in the other side of the screen to interact with us. We'll bring some topics to discuss. Oh, Professor Volker is here. Hello, Professor
Hi,
Volker. Nice to
Professor
have
Volta.
you directly from Australia. Nice.
Roberto, where are you from? Okay, we have someone from
Roberto
Munich.
Ken. Hello,
Good,
everyone.
gute Nacht, right? That's what I should say.
Guten Morgen. I think it's morning, right?
No, it's
I
nighttime
think
there.
so. I think so. Ah, yes, it's night. True. Yeah, it's morning here also in Brazil. Yeah, like it's also morning for you there, David, right?
Yeah, I'm joining everyone. I'm here in California, and Davi is in Brazil.
Yes.
All right, we have people from Hong Kong, Marina, California.
California.
Excellent. I was in Monterey, California yesterday, visiting the Monterey Bay Aquarium. So nice to see folks from here in California. London, Ontario. Nice.
Nice.
Okay, are you going to?
It's great to see like some folks that are with us like since the first webinar. So welcome everyone. And for the news ones, you like the new folks here joining us in this exciting community of people who likes to talk about space farming and agriculture, sustainable agriculture. So welcome everyone.
Yeah, I see people from India, from Hungary, from Tanzania, and also from Cancun. Buenos dias. Um, Great to have everyone. So, Davi, can you share your screen, or would you want me to
Yes,
share my screen? Okay.
I can share it. Okay. Let me know if you can see it.
Yep.
Oh, nice. Okay, so we are actually starting now. So first of all, welcome everyone. I would like to briefly introduce myself very quick. I'm Davi Souza. I'm together here with David and Nico's also in the technical assistant here in the background part, supporting us to make this happen. Welcome to the one more episode of the Space Ag series, specifically the Space Ag updates. So now I'll pass to David to start with the agenda and the initial considerations.
Perfect. So, good morning again, everyone, or good evening, wherever you're located. Once again, Space Ag Updates is a series. We have episodes about every month and a half or 2 months. And those series, those webinars alternate between having an space expert guest join us. So we had Professor Volker, who's here with us today. He was our expert speaker um, for our last episode. And then we have these Space Ag updates where we share news that's related to space and encourage you to participate as much as possible. So, what we'll be doing shortly is going through some news items relating to space agriculture. And while that is happening, if you have any questions at all, please add them to the chat and we will address them. And then later on in the session, we'll have a couple of, we'll have some conversation items and we'll ask you guys if you're interested to just open your mic and share your thoughts about the items that we're discussing. Additionally, just if you have questions about, relating to space ag in general, please feel free to post them, and either Davi or one of our other experts or one of our guests can can answer them. What we really want to do is foster a conversation here, um, and so I hope we'll get lots of folks joining us. All right, next slide. Okay, and what is SpaceX updates? We just discussed this, but it's really what we said today. We really want to get a lot of interaction between the folks on this call. Um, and once again, my name is David Caesar. I'm the lead agronomist for Agritecture Consulting, and I'm based in California. And we have Davi Souza, who's a space ag expert from Brazil. All right, now a quick little bit of humor to start off the day. What insect can you expect to find on the moon?
This one, let's see if we have any answer previous than moving forward. Does anyone has any idea? I don't think so. If you have also your jokes, also bring them to us. We'll be more than happy to share here with everyone. Okay, while you think about the answer, like at least the next joke. So the answer is a
A lunar,
lunatic.
a lunatic, yes.
Yes. So now let's move to the news review. Well, let me tell you that this was a very exciting. We are right now experience a very exciting momentum of space farming because we are hearing about it a lot of the news. If you are not, I would say like go check a bit further and you see that at least any specific topic related to space might have a small topic regarding space farming, someone doing some plant biology experiments or sending something to the International Space Station. Actually, this is happening on a regular basis. But I think the most hot topic that we have now, and a lot of people have been discussing the previous week, actually, it's the mission from Blue Origin. They had their 31st mission that they sent to space, and this mission was like got a lot of attention from the media outside. A lot of people talking about this because we have some remarkable achievements that we can discuss and present here. So the first one is that this was a historic all-female space tourism suborbital mission. So as you can see, this is the crew. We had like singers like Kate Perry. This shows exactly the intersection of space with STEAM topics, which has also arts into it. But also, I want to like just highlight the participation of um, one spacecraft engineer, a former engineer from NASA, Aisha, and she was responsible to conduct a very exciting plant biology experiment in this suborbital flight. So I would say that these are the two remarkable ones that we want to mention. But I think, in my personal point of view, I would say that this is very exciting to see that we are not only have scientific missions in missions together with the space agencies like NASA or ESA, but we are now seeing a new movement into the space farming sector that we have now tourists, space tourists, or like people who are doing tourist missions to space, conducting this type of experiments. And this mission is the best example of it because it was like a bunch of media around it, and we are seeing now the potential of not only the space tourism to have also the presence of the woman figure in the space flight, because this is a very interesting term. Not sure if David ever heard about that, but a lot of people, they say that this is a uh, uh, manned mission. So we are now having this transition to have, we are not only have missions with men. So we are having also missions with women. So they are also present in the space exploration sector, in different sectors of space, actually, of the space industry. And it's very important for us to highlight that as a remarkable achievement. And just for to let you know, the previous all-female mission that we had was during the Soviet Union, that they sent one woman to space. Um, in a very short term mission. But let's talk about the plant mission itself. This was an experiment, very exciting experiment, that they had the opportunity to cultivate some sweet potatoes, tomato seedlings, and also Arabidopsis thaliana. But another very interesting fact is that they sent also dormant chickpea seeds, and this chickpea seeds is from Brazil. So I got very like excited to see that we have some crops from Brazil going to space to conduct space farming research, and perhaps this might be the species of crops that will be feeding astronauts in the future on the moon, in future lunar settlements, or even in future Martian settlements. Um, and the aim of this experiment was basically very short, to assess the response of both the seeds and the seedlings to cosmic radiation exposure, and also to the microgravity environment, or the reduced gravity environment. Just to let you know, this is the apparatus that they sent. It was from a company called Bioserve Space Technologies. And this is a device that is very useful not only for biology experiments, but also for biomedicine experiments sent to space for suborbital research. They can preserve RNA, proteins, metabolites. They send these not only to suborbital flights, they send already this to the International Space Station, and also in other type of simulation flights, let's say like that, or some other types of other ways that we can simulate microgravity also here on Earth. So it's a really cool apparatus that we can do a lot of research with it. But I think the main point of it, and I would like also to hear from David after I mention here. What do you think about it, David? But I would say that a lot of people have been asking, like, came to me recently to ask, oh, but this was a very short-term mission, like 10 minutes, the whole thing. Like, you have a few minutes to go to space. They spend there, like, specifically, they spend there only 4 minutes. Um, After the Karman line, if you are not aware, you can see here basically the rocket sent the capsule above 100 kilometers of the terrestrial atmosphere. So this is already considered the space environment. And the crew spend there for these 4 minutes, and they are conducting this type of experiment. But as we know, a plant, the growth cycle of a plant is just like something very like way longer than that. Like what we can do in 4 minutes, like what is the meaning of that? We are just spending money for like to don't get any scientific results. And this is not true, especially because like we have many ways to analyze that. And but first, then saying the ways, I would like to hear from David. Like, what do you think about that? Do you really think, David, that in 4 minutes we can have scientific results from this type of missions?
I was surprised, to be honest, when I saw that I guess the whole flight was only like 11 minutes long, and I was a little bit surprised how you could conduct some sort of scientific research. But I guess if the question is, a very short um, exposure to a high degree of um, microgravity, that yeah, there is potential for um, some sort of change to the plants, to the cultivars, to the seeds, and yeah, it will be interesting to see what the result of this will be. Have there been? Are you, Davi? Are you aware of experiments that have tested this before, or is this the first time that? And what has the result been of those experiments in the past?
Actually, this happened already a lot at the International Space Station. Of course, for a bit longer time, but imagine if they are sending some dormant seeds, it's the same idea. They put this outside at the International Space Station, and this they send the seeds back to Earth, and they cultivate the seeds to see exactly if there was any change in gene expression. But basically, the main topics of it is like conducting research on genomic and transcriptomic screening during this mission, during the length of the mission. I will be providing more details about it, but we have two specific terms, which is called the plant adaptation and the plant acclimation. So the adaptation is exactly how the plants adapt to the long-term exposure to that specific environment. And the acclimation is how plants sense and respond to a specific um, signal, let's say, in the environment. And this is exactly what happened in this type of research. I would say that there is, I would not give that spoiler, but we have a specific slide saying, at least from the Chinese perspective, the economy behind this type of market, let's say like that, David. Um, we have a lot of potential to have more resistant seeds, especially if we are talking about climate change and all of this. This is a very important topic. So basically, in this experiment, they aimed to observe the molecular responses of the seedlings and also to see if there was any mutation or any changes on in the gene expression or in protein levels of the plants. Because when you send this to the space environment, we need to consider the exposure time in terms of not only the exposure time, but we also need to consider the intensity of that stressor. And this is exactly what happens. You are sending them these plants or this biological material, let's say like that. You are sending them to space, and the aim is exactly to evaluate higher intensities of cosmic radiation, because if they are like above on the atmosphere, they might have less, let's say, enclosure from the magnetic field of Earth. They feel like more radiation, more effects from radiation. They already feel the microgravity. So it's exactly to understand what really impacts on this stressor that is being introduced to the biological material. So with that, we can have many insights, not only for future space exploratory mission to grow crops on the surface of Mars, for example, but of course, we also want to understand how these crops can be used here on Earth, let's say, to deal better with lack of water, with drought, or like high temperatures and so on. And
We had,
go ahead, David.
I was just going to say there was one question regarding this, whether the seeds were contained inside or outside of the capsule. Um,
Actually, everything was inside of this. So let me provide the big picture. The the seeds and the material, the biological material, was inside this apparatus, these FPAs. Then it was on the lap of the astronaut, let's say like that, or the tourist astronaut, which was Aisha, and she was inside of the capsule. So the capsule also have um, it's not possible to have a full radiation shielding, but also has a radiation shielding. But of course, we have higher levels of radiation, so they can also track the amount of radiation that these plants perceive, and they already have an estimation of uh, the the gravity value in that specific place. So we have reduced gravity, so we have less gravity than here on Earth. That's why we can perceive the plants can perceive these changes in the environment that they are put in. I
gotcha.
think so. I think we can move on the next question. So, as um, as just happened, if you have any question, send on the chat. David is checking here. He can bring here to us, and we can just start a discussion based on that. So, moving to the next news review. This was another very exciting one for me. When it was announced, I was talking to some colleagues in the field, and I became aware about VAST, which is a space company that they are mainly interested in building the next generation of space stations. Let's say commercial space station. This will be the first commercial space station that they are expecting to launch in 2026. So, what is a commercial space station? Let me explain very brief to you here. we have the International Space Station, which is more like a governmental effort. Of course, you have companies involved and so on, but mostly we have countries there that they are collaborating to a bigger goal. Now we have some specific companies with the new space sector. We have specific companies with a specific expertise. In the case of Vast, they have the expertise in building these space stations, and they are sending these to space, and everything will be done. Like imagine like a hotel in space, in the low Earth orbit, and we can send astronauts, like commercial astronauts, there to conduct research, but also like perhaps as we have these tourist missions, we can have like astronauts just there doing tourist missions and so on. So basically, this Heaven One lab from Vast was developed with this goal. And what is most exciting about that is that perhaps you already, if you were here in the previous episode of the Space Egg Updates, the number one, I had the opportunity to discuss with Nico about some efforts of the Interstellar Lab, which is a French company. They are also based in the US. They also have an office in the US, and they are developing different type of systems to send to space, but not only to space. They are also developing systems that we can grow plants on Earth, like some high value crops, some medicinal plants, and so on. They are developing this. They have these two branches of products, let's say like that. And one of their products that they recently announced based on this partnership with Vast was the Eden 1.0, which is basically a plant growth unit, as you can see in the slide, um, in the bottom right corner. And this is a very small chamber to conduct this type of research that we saw in the blue orange mission. But of course, for longer term, like for we can have experiments now running for like terms of days, months, and even like for a full growth cycle. And here is just like this one section of this space station. This is the bottom part of the space station, not the bottom part, but one side of the space station. And they have different payloads or cargo. They call this cargo missions. Basically, this Eden 1.0 will be part of this cargo. As you can see a very small purple spot on it. This is exactly the LED lights to grow plants. And the first mission that they announced will be conducting research on roses on low Earth orbit.
How
And
how how large is that growth chamber?
oh, this is a really good like really good question, David. I didn't check this one, but I would say that this is a very short one. Okay, let me bring in terms of comparison from the International Space Station because I have the values. But basically, you have one payload hack um, at the International Space Station is 2 meter tall and 1.5 meter deep. So imagine that this full area might be something similar. So we are utilizing what 1/4 of this area. So it will be something like that
Okay, thank you.
in terms of dimensions. And in terms of capacity of operational functionalities, this is like an automated greenhouse with autonomous climate, light, and fertigation control. They mentioned that they will have several sensors and cameras for real-time monitoring. And this is kind of very similar on what we have at the International Space Station and the Advanced Plant Habitat, which we'll be discussing about this very soon. But in very short terms, this is now being conducted by companies. Companies, they are developing the economy behind of this type of systems, as we have here on Earth. People are developing their own, like companies are developing their small chambers, their own systems, and they are selling it. In this case, who are buying these systems or who are like utilizing these systems is mostly these commercial space stations, but also the scientific community. And of course, with the spin-offs of these technologies, they can bring solutions back to Earth. Um, does anyone has questions about it? I think I saw that we have one here in the chat. Not sure if the
No,
question.
I think that was from the
Okay.
previous item. Yeah, so we
Okay.
we
Perfect.
can move on to the next one.
Yeah, sure. Well, now let's. as I mentioned, we have the advanced plant habitat on the International Space Station. Different from a news, we are now reviewing a few articles discussing about some experiments or some things that happened recently in the field of space farming. This was suggested by David, by the way, so it was a really good suggestion. And going further on this, like you can see the source of the articles, we have two sources on it. One of them is a poster made by NASA scientists, but they also shared more details about this mission in their website. um, and if I'm like Professor Volker might correct me, but if I'm not wrong, the group that Professor Volker is part, they're also contributing to this experiment. If I'm not wrong, I saw very short like that. There were researchers from Australia too conducting this research, like contributing to this research. But basically, the plant habitat 07, it's basically space botany investigation. As you can see, they grow red romaine lettuce. And why this crop was selected? Basically because NASA already has a lot of knowledge on how to grow this at Veggie, which is the other system aboard the International Space Station. But now they are evaluating different responses. And the good part of the APH, or the Advanced Plant Habitat, which is a growth chamber, um, at the International Space Station, is that it also has the real-time monitoring, the autonomous capacity to study the plant responses, the plant physiological responses. Specifically, this experiment, they tried to understand exactly the water stress in microgravity. So what happens if you have different levels of water being delivered to these plants in microgravity? So um, as you can see in the right figure, in the most right figure, this was shared in the poster. I think this was some initial experiments that the scientific investigation that they conducted here on Earth, previous than sending this to space, exactly to see what to expect, what findings they can expect, and see how the system will perform during this experiment. And this is really cool because all the system that NASA has at the International Space Station, they also have this back on Earth, exactly to simulate both of things simultaneously.
So we have a question, Davi, from one of the participants asking, like, are these types of studies, are they publicly available? Are all the results publicly available?
Yeah. Um. Okay. Perhaps the link here I can put once I finish the presentation, or you can simply search for plant habitat 07 NASA. You'll find this poster here. They have the preliminary results discussing about the experiment.
But I
So
think
this,
I think the sorry to interrupt. They're
yeah,
asking
sure.
sort of like more in general when these types of space ag experiments are conducted. Are the results generally published and anyone can see them, or are they kind of kept more secret?
Yeah. So keep the eye on scientific publications. This happens a lot. Sometimes in well-known scientific journals like Nature, Acta Astronautica, there are like different journals that the researchers they share this. But this, I think, this is a very interesting policy from NASA. They share also everything open access in NASA website. So of course, if it was a researcher conduct by a NASA researcher. Like they share everything in their website. So I would say that the best way to find out is like that. But of course, for now, this type of experiments we can find very easily. Just search on Google. Different researchers are conducting different type of experiments. From what I know, there's the one researcher interested on exactly on the drought, let's say drought modulation in microgravity, is Professor Oscar Monge from NASA, and he's very interested exactly in computer vision, for example. This is one topic actually that I had the opportunity to cover in the Space Farming 101. That Professor Monge, he conducted the studies utilizing some thermal cameras to understand exactly how to track the drought stress on the plants, not only on Earth but also in space. And the data sets that he utilizes was also from USDA. So it's exactly merging both interests to a common goal. But yeah, answering the question, you can easily find the results Of course, some of them might be not publicly available for now, like this one, perhaps they're still conducting the experiment and so on. But I would say I keep the eye open and search for the upcoming experiments. They are always sharing about it.
Okay, great. Perfect. Let's move on to the next article.
Sure. So this is another very interesting point. I would say, first of all, this is not like my expertise, which is pathogens or like biological contaminants and all of this. But this was a very fun fact because one of my followers on Instagram, he just sent me this news like that. Hey, do you really think that the astronauts are eating contaminated food? I was like, what? Calm down. What? Let me learn more about this. And and this was interesting because I saw this news that yes, some research I think from the University of Delaware, they identified some issues or at least some concerns about this, how salmonella reacts on the plants, basically this interaction, how this interaction happens in microgravity. But of course, as we see, that is not that we are saying that NASA is giving contaminated food for the astronauts. It's not like this. We must go further, and this is a recommendation for those who are interested in the topic. Go further, go to the article, see the group that conducted this research, try to understand the behinds, or at least the background of the research. Try to understand how they came to this conclusion, because of course, as most of us know, sometimes the media, we see some type of news that is not exactly what happened, but it's related to what happened. Um, so this is a critical thinking that I'm suggesting for all of you here that is watching today to understand, to go further in these space related topics, but not only space related topics, any type of scientific topic that you might find a paper available online. So the paper specifically that they published the paper on Nature, which is a well-known scientific journal, as you can see here, the link below. Um, and what this was a very interesting for me when I saw it. Like this paper was between among the top 100 of 2024 on microbiology. The aim of the study was to understand the stomatal dynamics under microgravity conditions. So what they did for that, as you can see on the right text, they basically employed a slow rotating 2D clinostat. What is a clinostat? It's an apparatus that you can simulate microgravity or reduced gravity here on Earth. At 2D, of course, it will move in just two dimensions. You also have like random positioning machines that you can, it rotates in three axes. But this one in two axes, they conducted this experiment with in vitro lettuce plants, and they did foliar inoculation of Salmonella bacteria. And what was very interesting is that that's true. Basically, previous studies from NASA and other space agencies, they identified that there is already salmonella in space in the International Space Station. This is true. They found considerable levels of this bacteria there, of course, because we are sending human beings there and another type of biological material. So you cannot avoid full contamination. But on the other hand, with their studies, they see that there is a potential spaceflight food safety issue. Why there is a potential? It's not that astronauts are eating salmonella, but there is a potential way. Like their findings and evidence shows that demonstrates that perhaps this might happen in space. And how they did that? Basically, with this inoculation of the bacteria, uh, here on Earth, this was conducted. A clinostat is like simulated gravity, simulated reduced gravity here on Earth, and based on the levels that they have there at the International Space Station, and also with the inoculation that they did here in the similar levels, they saw that there is a bacteria like they call PGPR. The whole thing is called plant growth promoting rhizobacteria. This is a bacteria responsible to restrict stomatal aperture. So just how how much the stomata will open or close. And their findings, they saw that in microgravity conditions, this bacteria, this rhizobacteria, reduces and restrict the capacity of the stomata to close or to open. Like it's kind of, let's say, it's not random, but let's say it's like they make easier the salmonella to contaminate the plant. And this is exactly the bacteria that avoid the salmonella to contaminate the plants here on Earth, because this is a bacteria that we have a lot on Earth, and the plants develop this exactly to avoid this type of contamination, these pathogens, biological pathogens. So this is the whole picture of it. What I can say is that um, these are some terrestrial findings, of course, with simulated environment, in a simulated environment, but they only simulated one variable, which is gravity. We also have many other variables. We have temperature, we have humidity, we have also radiation in space. And this might change at the International Space Station, but also this might get worse. And the only way to find out is sending, now that they have these preliminary findings, the idea is to send some sort of experiment to the International Space Station to evaluate how this will be, like how the plants will behave on in these environments. So this is a big picture of it. Do you have any question, David?
No questions, but I think
Okay.
it's just a good reminder that, if you're working with plants, if you're working, especially in the controlled environment agriculture industry, right? There's so many variables that you need to consider all the time, and just because you have results under one set of conditions, right? Changing one condition, whether it's temperature, humidity, the type of light, the wavelength, the photo period, the intensity. There's so many factors that we can change in, or so many parameters that we can change within CEA. Any of those things, could result in changes that are expected or unexpected. So just keep that in mind, especially when you are reviewing, scientific literature, and you see a result that, oh, this is great. I'm going to use this kind of crop recipe for, growing my lettuce or my kale or whatever crop you're growing. And then maybe in your specific conditions, the results aren't the same. And, it's because your environment is a little bit different than where that study was conducted. So just a good reminder of, be aware of all the parameters that are affecting your plants, and try and be as pay as much attention to exactly what's going on across all those parameters.
Yeah, utilize your critical thinking. Yes,
Exactly,
exactly.
for sure.
So, and moving to the last review, this is more, I would say, space technologies applied to agriculture. Is not exactly space farming, but I think it's very important for us to understand the role of the spacing industry here on Earth. As we mentioned, like all of this, that all of the topics that we mentioned so far, they are much related to controlled environment agriculture and technological solutions that we can also use here on Earth. But also, we send a lot of satellites. Human beings already send a lot of satellites to the orbit of Earth, also to explore the deep space and so on. And with the technological capabilities that we have now, we also have opportunities to try to solve problems that we are facing here on Earth. And this is a great joint effort between a company called Thales Alenia Space, which is an Italian company, together with the European Space Agency, that they are now focused in developing an agricultural digital twin component for sustainable and resilient agriculture. If you want to learn more about digital twin side, I would really recommend you to check the YouTube channel of Agritecture and see the last Space Ag conversations, because Professor Volker also presented this to us. And this specific project or component, digital twin component, called Safe Crops for EU, it has some scientific pillars, but I want to just summarize here that the idea is now that we are having better technology that are sent to space. We are having like more rockets being sent into space, more payloads, more satellites, and so on. And we should also utilize this in the benefit of our planet. So in this case, in this project specifically, they are interested in agronomic indicators, understand conduct the real-time analysis of crop conditions, provide you for yield forecasting, understand like estimation of production volumes in specific regions. This might be more in the EU, but of course, like if it's a good result, this can scale to the whole planet. And also, as we talk already about the stressors and so on, try to see some regions like to identify like the models can also test the incorporation of different stressors, like either abiotic or management strategies and so on, that we can try to understand if this happen in a specific region. So if there is a stressor, like if there is a heat spot, let's say like that, in a specific region, um, and we don't know what happened there, but with the digital twin models they can start trying to do some forecastings and understand what is the impact of this heat spot on the plants, and understand the whole chain of production and logistic and so on. So this is just one great example of how space industry, how space technologies can be useful also for us in different fields of agriculture. Now let's move to the next joke. I talked a lot. I was telling to David that my voice, I'm not with a good voice, but like to talk about space farming is always exciting for me. There's no way for me to avoid that. Um, but yeah, like the next joke is like, what will we call the first space currency? Any ideas on that? Does anyone know? Mooney. Oh, this was a good one, Greg. This was a good one. Yeah, I think this can be also another option for that. Any other inputs? Does someone wanna share any idea? Dogecoin. Okay, the nice one. The cryptocurrency, the space cryptocurrency. But I would have like I really like it this answer, um, which is the Starbucks. So the future currency in space, the Starbucks one. So now I'll pass to David
Okay,
to give some insights on an agritecture side.
yeah. Just very quickly, we wanted to let you folks be aware of a couple things that we have coming up. One is Green Tech is coming up in Amsterdam in June, and Agritecture will be having a CEA business workshop. Um, so that's happening on Thursday, June 12th, the morning of Thursday, June 12th. So, in case you're going to be in Amsterdam and attending Green Tech, um, please consider attending the workshop. Next slide. Another thing I want to let folks know about is we are going to be launching the 2025 CEA census shortly. And in the past, the CEA census has been for just for farm operators. But this year we're doing things a little differently. And the focus of the census this year is going to be CEA and AI, and trying to get people's opinions about what you think the impact of AI will be on the CEA sector. And so this year we're going to be taking responses not only from farm operators, but also equipment suppliers. You know, if you're a lighting manufacturer, if you make some sort of equipment and you're incorporating AI into your technology in some way, we want to learn from you about, you know, how that's going to increase the productivity, how it's going to increase the cost, what are going to be the advantages for the farm operators. We also want to have folks just from the industry participate as well. So Davi will be a participant. He'll answer the questions in the census, and we'll get his opinion based on his uh, just expertise. And we want anyone who's involved with the industry or interested in the industry who has an opinion of this to give their to participate. And next slide, please. And
Previous
as
than moving, just one thing, David.
yeah,
I would totally agree. I'm happy that now I can contribute to the census. And I think this might be a really good opportunity for us to ask for those who are here with us to put a poll on what is your field of interest. What do you think about it? Nikos, can you support us on that, please? Okay. Let's see how many people we have to contribute to the census. I think all of them, huh? Meanwhile, some of you are answering. I think we can jump for the next slide, David.
Yeah, and just as one perk, um, as part of the census, we're going to be giving away some free trips to a conference in North Carolina, I believe, in the fall, CEA Ag World. But we'll also, everyone who completes the census will be able to take advantage of 1 year free Agritecture Designer. Um, and that's our software, which allows you to design CEA, do CEA business planning. Um, so we encourage folks to, uh, once we announce the census, to take part. Um, should we jump to the Q&A since we only have about 10 minutes left? What do you think, Davi?
I will. I think so. Let me just let people know that well, together with the Agritecture Designer software, we also launched, maybe you are all aware, the Space Farming 101, which is the first online course on space farming and its technologies. We discuss about most of the topics that we are discussing here. Actually, the Space X series is, let's say, a spin-off from our collaboration from the Space Farming 101. And here, just for you to have an idea, this is a sneak peek of the module 3 that we discuss about life support systems to understand what happened at the International Space Station, the crops that was grown there, understanding about exactly the topics that we discussed today, abiotic stressors, severity and duration, exposure time, understanding how the plants perceive the environment, exactly this formula of phenotype equals to genotype plus environment, and the different stressors of the space environment. Also, the plant physiological responses, what happens when we have light or we don't have light in space, or when we have the 1G, like the gravity on Earth, or when we have like microgravity environment. So understand how this impacts the crops and which crops are more dependent on it or not. And in a general perspective, as I mentioned, the acclimation and adaptation, how are plants affected by the space environment. So everything of it is highlighted at the Space Farming 101, and you can find this at the website provided here down. Just go to the Agritecture Designer website. You see the premium courses part on the right top corner, and you can have access to it. And I'm pretty sure that you will really enjoy the topics there if you are a space farming lover.
Yeah, if
So
you want to
gently.
learn more about all this stuff that Davi's been talking about in much more detail, then please take his course. Um, let's open it up
and
to questions.
and I just have one last one, two questions. But if you are also like, if someone here want to ask questions, please do it. We'll be more than happy to answer them. The next thing that I want to mention is that together with the Space Ag series, we created a monthly newsletter on space farming, which is the Space Egg Wrap Up. And basically, this is a place that we can have you'll be receiving in your email the upcoming events, some technical articles, opportunities in the field, and other space-related updates. And of course, if you are here with us until now, like don't forget that next month on May, we'll be announcing our next guest speaker for the Space Ag Conversations episode number 3. So now I think let's jump directly to the Q&A. The After the jokes, of course, the joke of the 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 radio in space, what the astronaut listen, which is the Neptunes. Um, and to start the Q&A here, I want to just like promote one debate question. I think it's a good way for us to get your opinion. And if you are interested to join, open your mic, feel free for that. Which is how CEA and agtech sectors can benefit from space economy. I think we showed a lot of this. You might already have many reasons, but we want to hear from you. Which are your reasons for that? Does anyone want to jump in, open your mic? Feel free to do that.
Okay, we have a question. Let's see. What kind of lighting is used in the ISS plant habitat? What wavelengths and or spectrum?
So we have two different ones systems operating there, which is the veggie and the advanced plant habitat. The advanced plant habitat has more, I would say, the dynamic light capacity, which is basically you can select spectra and you can select the intensity. So you have more like it's a more controlled lighting system. So at the advanced plant habitat, you can put green, you can put like blue, like the normal, like the like usual ones that we have in controlled environment agriculture. But of course, some specific plants might have different requirements and they can change based on that. Veggie itself is a more like the basic blue, red, and white light combined. It's a like a more standard like lighting system that we have here on Earth, exactly to have necessary intensity. If I'm not wrong, also they put some far red spectra on that to see how the plants behave with the far red, as we already know that there are some impacts of far red on the plant growth. But veggie basically, since veggie is more like a space garden than like a like a scientific a system for plant physiology to study plant physiological responses. Veggie is more simple. The idea is exactly like to grow crops in a more simple manner for the astronauts, just to see like how the plants grow and how they can eat these plants.
Are they are the is are they using like off the shelf lighting? Are they buying lights from a equipment supplier that is supplying vertical farms, or is this like special custom made equipment that they're using in these?
Oh, this is a really good question, David. First, Veggie itself was one of the initial systems to test the LED grow light, as we know commercially. So most of the research, far red is up. Yes, exactly. Infrared, Gur, is basically just answering your question. Infrared is heat. So the veggie system, it already has the thermodynamic system, like the thermal system at the International Space Station to control the heat itself. But I think mostly far red, it's up to far red is the one. But returning to this idea, veggie was the one that conducted the initial studies on it on LEDs applications for plant growth. And but I'm aware, and this was a system developed by NASA. This was a board, like a lighting board developed by NASA. But I'm aware that some in the NASA laboratories, there are some researchers that they are utilizing Osram lighting board. Um, that they offer like more interactive software for you to play with the spectra, with the intensity, and so on. So this is easier for a researcher conducting like the researchers need to get a lot of data, a bunch of data. So if you have a software to make things easier, is much better. Uh, okay, we have here. Thank you, Roberto, for this feedback. Much appreciated. Also, if for those who are here and if you are interested to join the Space Ag newsletter, feel free to add on the chat like that you are interested. Just put like add me on the newsletter, and we'll be tracking your we'll be adding you like your email on the mailing list. We have also a comment from Good. So yes, infrared is not always heat, but if you see the responses of plant like with for example with the far red, the idea to utilize far red is mainly to get like the plant response to shading. So you want to make the canopy of the plant to like have like to develop better. So when you are adding infrared, like perhaps there might be some specific, I would say, some specific plant responses that might be interesting. But at the International Space Station, they will not, they won't, don't want to utilize this type of things because you are already consuming a lot of energy to remove the heat from the technical equipments and all of this. So you have a very controlled environment. And if you have something that you are adding more heat to this environment is not beneficial. For example, veggie itself, it has some ventilation, some cooling fans, exactly to promote the air circulation, but most of the temperature and the relative humidity in the environment, in the plant microclimate, is controlled by the International Space Station environment. On the advanced plant habitat, this is everything controlled from here on Earth. It's a like they have their own, like they even can control the pressure. So like it's basically on the levels of it. And if there is a specific application, I would say that this might sound interesting, but I'm aware that at least for now, there is no infrared uh, LED chip, let's say like that, because some different spectra. If you have wide spectra, you might have some part in the infrared region, but it's very minimal. So
Okay, we have about just one more minute. Any last questions that we can address? Um, I think
okay.
everyone's very quiet today. Um,
Yeah, I've
so,
actually I can bring one more question. I think this was from the external participants, and they ask exactly like just a note. We cannot open okay, they cannot open the mics.
oh, that's
Oh,
okay.
thank you
Yeah.
for the information, Greg. Does anyone want to jump in? Please feel free to add in the chat. Perhaps we can open the mic and for you to make your question now at live.
Davi, you said you had a
Yeah.
question from someone else?
Yes. There was one question from external, like people interested. I think it was from Good actually. He sent via email to Nico, and I would say I choose here Good the question related to low gravity effect on plant growth. And okay, there are more questions here, but okay, just talking about the low gravity very short now. Basically, we have the effects of gravitropism on the plants, which I previously mentioned. So imagine like that, as we have the light, the phototropism pushes the plant up, the plant canopy up, and the gravity pushes the root of the plants down. So you have basically this relationship on Earth, but in space, of course, you do not only have the effect of the lack of gravity or like reduced gravity, but also it changes the water dynamics, so the fluid dynamics in space. And the idea is like it's to understand exactly like for different levels of gravity, what do you need on the system to like to provide to promote the same responses as we would have with gravity here on Earth. The solution for that is exactly the LED lighting that we were discussing for now, because if you can promote the shoot development, the canopy development with the light, with the phototropism, the plant starts to promote the root orientation. Like it's like a mirror. What happens on the top will happen on the bottom part of the plants.
So you're saying that you can overcome the lack of gravity by using by with the phototropism,
Yes,
essentially.
yes, exactly. This was exactly what motivated these advances in LED lighting along the years, actually.
Okay, we have one question from Juan Carlos. He says, "What differentiations can be achieved in space in order to be economically viable?" to produce some plants, maybe to producing chemicals or something. Let's see, because there must be some initial economical motivation to produce there, maybe harness the microgravity plant metabolism environment to produce expensive chemicals, materials, proteins, etc. I don't exactly understand the question. I'm not sure if you do, Davi.
I think if I understand correctly, it's like if you have a product or a solution coming from space, what is the big thing of this product? Correct me, Juan, if I got this right or wrong. Like economically talking.
Or maybe what he's saying is if we're going to establish some sort of colony on another planet, um, does it need to start with some sort of economically viable crop there? Um,
Ah, okay. Produce tomato is not gonna be economic logical. Okay. Well, most of the research, like, I'll give the example of tomatoes. Space research, they were one of um, the fields that explored also the dwarf plants. So like there was a professor, I think Professor Bruce Bugby from Utah. Um, he developed some type of plants like dwarf wheat or dwarf tomatoes. So like it's this genetic this breeding process is also important to in order to adapt some higher crops, some staple crops, and bring these crops to the menu of astronauts in space. Economically talking, let's say, okay, what are the economic constraints? Let's say weight or mass to sending the rocket. This can be overcome if you are sending seeds or in vitro cultivated plants that once you reach in space, you can simply start propagating it. The second constraint would be volume area. If you are having this type of dwarf plants, or in the future, if you find a specific technique that you can, for example, let's say for the tomato, if you do the like you if you conduct the tomato to grow like in a more compact area, for example, can be another solution. But I would say that most of this to overcome the volume and space limitations will be mostly related to breeding programs. And I would say the last one is energy. So, well, in space, it's expected that the habitat needs to function really well. Um, in order to support life of the astronauts. So for that reason, there are a lot of like other fields in the space industry. They are interested to understand like the application of solar panels on it, or even like nuclear reactors to support the energy aspect of it. But for now, if we are talking about going to the moon, like okay, this might be like you might have, oh, it's not that economically feasible, but it's like not that bad to do this, to send crops to grow on the surface of moon. But if you are talking about going to Mars, you really need to do that because it's it gets more expensive to send the plants or some specific like sending food to the astronauts in exploratory missions, like sending the rocket to Mars with the food for the astronauts. So then you have like more economic viable products in space.
all right. Thank you, everyone, so much for joining us today. Once again, if you um, want to be receiving the newsletter, please let us know here in the chat. We'll be having a Space Ag update or Space Ag conversation sometime in May with another space expert, which will be announced shortly. Um, and the video recording, as Nico said, will be uploaded on YouTube as well. Um, but once again, thank you to everyone for joining us. Really appreciate your time, and um,
Thank you all for interacting, for the questions, and looking forward to see you soon in the SpaceX Conversations number 3. See
yeah.
you.
All right, take care, everyone. Have a great day.
Bye bye.